subject name is transmission of electrical power. The transmission of electrical power is one of the important part in power systems. First of all, we know the power system classification. Power system can be classified into three important systems. One is generation, next one is transmission, and last one is distribution. The power system can be classified into generation, transmission, and distribution. Now, we will discuss what is the importance of transmission system. Before going to that, already we know what are the different generating techniques. By using conventional and non-conventional energy sources, we will generate the electrical power. We will generate the electrical power with thermal power plants, hydro generating stations, nuclear, and gas generating plants is also there, and solar generating stations, wind plants or windmills, ocean energies like ocean thermal, wave energy, tidal energy, biogas, biomass, and geothermal, fuel cells, and so on. Lot of techniques is there to generate the electrical power. Okay, now these are the different generating techniques. By using those techniques and so on techniques, we will generate the electrical power. But our load is there at distribution system. A distribution system is responsible to give the power to corresponding load. Okay, now it is not possible to install all the generating stations near to the load centers. Suppose, for example, if you take the thermal power plant, it's having its own site selection procedure. Hydro plant is also having its own site selection procedure. It is not possible to near to the load centers. Nuclear is also okay. It is a specific site selection. It is far away from the load centers. A nuclear power plant in safety point of view. And wind is also where we have the high wind energy, where that places only we will install the wind power plants, ocean thermal, geothermal, tidal energies, wave energies. Okay, those are, it is not possible to install near to the load centers. Okay, therefore, by using this gas, solar, biomass, biogas, fuel cells, we can those are near to the load centers. But practically, we will generate huge amount of electrical power with the help of thermal plants, hydro plants, or non-conventional and conventional energy sources. In this fossil, by using fossil fuels, we will generate huge amount of electrical power. Okay, those are not near to the load centers. Therefore, we need a transmission system. We need to transmit the power from generating stations to load centers. Therefore, that is the importance of transmission system. Transmission system is responsible to transmit the power from generating stations to load. Okay, therefore, as electrical students, what you learn from this transmission of electrical power? In transmission of electrical power, we learn about how to build a effective transmission system. What is mean by effective transmission system? Effective transmission system have more efficiency and less percentage of regulation. Okay, then this transmission system is called effective transmission system. In this subject we learn about how to build a effective transmission system. Before going to that, we know the efficiency formula. Efficiency equals to output by input. We can write this input is output by output plus losses also. If losses is less, then automatically efficiency of the transmission system is more. Now, how to reduce the losses? How to reduce the losses? Already we know that the losses are nothing but I square R losses in overhead transmission or underground. I square R losses. This is for single phase. 3I square R for 3-phase system. 3I square R for 3-phase system. Here question is how to reduce the losses. How you are reducing the losses. The losses can be reduced by reducing the current and resistance of the transmission system. First we will see how we will reduce overhead losses. Okay. Now assume a generating station. This generating station is far away from the load center. We will connect with the help of a transmission system to this generating stations to load. Assume that the resistance of this transmission system is 10 ohm. Here P equal to V into I. Okay, I am generating 50 volts for example into 2 amperes, then power equals to 100 watts. Assume that cos pi equal to 1. Next, calculate the losses for this transmission system. Suppose it is a single phase transmission system, the losses is I square into R, therefore it is 2 square into 10, we can get 40 watts. Then the output is equals to power at load equals to 100 minus 40, we can get 60. Therefore, efficiency of this transmission system is 60 by 100. Output is 60 and input is 100. Therefore, we can get 60% of efficiency. Can we say this is effective transmission system? No, it is not at all a effective transmission system. Then by using the transformers, we can make this is effective transmission system. The generating station, same here also load. We are connecting this generating station and the load with the help of step up and step down transformers. Here we having step up and step down transformers. This is step up, this is step down transformer. Same here I am taking same voltage 50 volts and 2 amperes. The transmission line resistance is 10 ohm. Okay. Now the input of the transformer primary is 100 watts. We know the transformer, both primary and secondary power is same. There is no change in power. Okay, both the cases primary and secondary power is same. In primary side we are having 100, then secondary side also we are having 100. Therefore, I am step upping this voltage. To 50 to 200. Now the secondary voltage is 200 volts. Then what about the current in secondary? It is reduced to 0.5 amp. Now amount of current flowing through the transmission line, now it is 0.5 amperes. Now calculate the losses. Here I square into R, it is 0.5 square into 10. You can get 0.25 into 10, you can get 2.5 watts. Now again it is a step down to this voltage, this 200 is step down to 50 volts, the current is 2 amperes, now power is same. Here. Why you are choosing the transformers for transmission system is, We know there is no rotating parts in the transformer. The efficiency of that particular system is less. The efficiency of transmission system, the losses of that particular transformer is less than efficiency of the transformer. If you calculating the transformer efficiency, it is more than 95%. That's why I am choosing the transformers. Okay. Therefore, how much power you get here? It is 100 minus 2.5. You can get 97.5. Therefore, now efficiency of this transmission system is 97.5 output by 100. You can get 97.5 percentage of efficiency. This is the way, by using these step up and step down transformers, we will reduce the current when transmission losses are reduced. Now also another method is also there to reduce the losses. Losses equals to I square into R. Now we seen how to reduce the current. Now we have another option to reduce the resistance also. Resistance is, we know that rho L by A. It is rho equals to resistance, resistivity of the material. Rho equal to the resistivity of the material. Resistivity of the material. What type of material we are using for the conductor? We have to choose low resistance, means more conductance material, and L equals to length of the transmission system, and A equals to cross sectional area of the conductor. Cross sectional area of the conductor. How to reduce this resistance? This resistance can be reduced by choosing low resistance material. If you observe in overhead transmission system or distribution system, we are using the conducting materials or copper conducting materials and aluminum conducting materials. Widely we are using copper conducting material and aluminum conducting materials. Those are the good materials for transmission of electrical power. If you see the properties of a conducting material, comparison with the conducting materials, the copper conductors are having good conducting properties, and aluminum having good conducting properties, but compared to copper it is having less conductivity. Compared to copper it is less. Now second comparison is specific weight of the conductor. Specific weight of the conductor is more, then we need to install a stronger support to the overhead transmission system. The copper conductors having more weight compared to aluminum, the specific weight of the aluminum conductors are less compared to copper conductor. Therefore, no need of a stronger supporting structures for aluminum conductors. And also we have to take another comparison, that is availability of the material. Copper conductor is not available compared to aluminum. Aluminum is wide range of availability. That's why we are preferring aluminum conductors for transmission systems, copper conductors for distribution systems. If you observe in your homes, the conducting material, you will check the conducting material in your wiring, in home wiring, it is a copper conductor. Reason is it's having very good conducting properties compared to aluminum. Okay, but aluminum is used for transmission systems because wide range availability of the material. Okay, this is about the materials used for overhead transmission systems. Now, what you learn from this subject is, what are the topics we have to discuss in this subject is, we have to know the topics. The topics are The efficiency of the transmission system is depending upon losses. Losses is nothing but a resistance, and regulation is depending upon, the formula for regulation is I into R cos phi plus or minus I into x sin phi divided by V2 into 100. This is the formula for regulation. For calculation of efficiency, we have to know the resistance of the transmission line. For regulation, we know the resistance. Reactance. Reactance of the transmission line, maybe it is inductive reactance or capacitive reactance. We have to know both the parameters of transmission line, inductance and capacitance of transmission line. Therefore, in this subject, first we will learn how to calculate the parameters of transmission system. The parameters of transmission system is R, L, C and conductance G also. Okay, but in transmission line analysis, we will neglect this G. This is leakage conductance from the insulators, a clearance between the conductors. Okay, then it is very low value in practical transmission system. That's why we are neglecting these conductance. We will concentrate on calculation of RLC parameters in this subject. First, we will learn how to calculate resistance, inductance and capacitance of a transmission line. That is first concept. And second concept is classification of transmission line. The transmission lines are classified into small short transmission line, medium transmission line and long transmission line. In what basis it is classified, the transmission line, and how to evaluate the performance characteristics of transmission systems, that is calculation of efficiency of that particular transmission system and regulation of that particular transmission system. That is third one. The second one is that one, and third one here, the mechanical design of transmission system. What is the mechanical design of transmission system? Mechanical design is nothing but what is the distance between the conductors and supporting structures, in what basis it is. In this, we have to know the corona in overhead transmission system. In corona, we will discuss about what is meant by corona formation of corona. What are the characteristics of corona? Means critical disruptive voltage, what is meant by visible voltage and power loss due to this corona formation. And also we will discuss about how to reduce this corona loss in overhead transmission system. Those topics we have to discuss in corona. And also we will discuss insulators, why we need insulators in overhead transmission system, importance of insulators, types of insulators and voltage distribution in across the string, what is mean by string efficiency, what indicate how to calculate the string efficiency, and what the information we get from calculation of this string efficiency. Next, we know how to improve the string efficiency, what are the methods to improve string efficiency. Another topic we have to discuss in overhead transmission system, that is nothing but sag. What is mean by sag? What if you are having tight sag or loose sag, what are the drawbacks? How to calculate sag for equal height of the towers, unequal height of the towers, and what is mean by sag template and stringing chart. What is mean by sag template and stringing chart. This is about overhead transmission system. And also we will discuss what are the transients, effect of transients in overhead transmission system, that is fourth one, transients in overhead transmission line. Okay, means any transients, suppose it is a transmission system, transients are induced in the overhead transmission system, how they will behave if it is connected to a resistance, how much traveling wave transmitted through this resistance and reflected back. This is incident wave, this is refracted wave, this is reflected wave. How much voltage, suppose it is a voltage form, how much voltage is flowing through the resistance, how much voltage is reflected back. Suppose it is a inductor, how it will reflect or refract. It is a capacitance, it is a divided into nominal T network, and if you are connected to a impedance and it is connected to a underground cable ZC, it is represented. How much reflected and how much refracted, we can calculate from this transient analysis. And fifth one is underground cables. Underground cables. In underground cables, we will discuss about why we need these underground cables, where and when we will use these underground cables. And second one is construction of underground cables. What are the layers involved in underground cable construction, and we will discuss types of underground cables, and also we will discuss how to calculate the resistance and stress in a underground cable, and stress distribution is not uniform, then how to give the gradients, cable grading techniques, how to distribute the stress equally to the layers of underground cable, and also know the how to calculate capacitance in a underground cable for single phase line and three phase cable, single phase cable and a three phase cable. How to calculate capacitance of underground cables, we learn from this subject. Okay, thank you.